Hey, Algebra 2 class, welcome to another algebra lesson. Today's algebra lesson is 11.6, Trig Equations. Trig Equations is my favorite lesson in this chapter. It's pretty simple to do, and I think it's something that you can work out, and something you should be able to fix up pretty easy. One of the big things that you want in front of you is that trig chart that you have, with all the exact values of the special angles from 0 to 360. Those angles would be 30, 45, 60, 90, 120, 135. And also, I'm going to be doing some of this in radian form, so hopefully you have all the radians there. I know in previous lessons I gave you all the radians, like pi over 6, pi over 4, pi over 3, all of those. So, as I look at this, the first thing I see is square root 3 over 2. Now, I'm just going to I'm not going to give you a whole trig chart. That'd be really, really tough for me to do. But I'm just going to give you a couple parts of this trig chart. The first one being degrees, radians, and sine. Okay, because see, it's here, it's sine. If this were cosine, I'd want to look at the cosine chart. If we go down degrees, on a trig chart, you got 0, 30, 45, 60, 90, so on and so forth. In radian form, it's 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, and 2 pi over 3, and so on and so forth. Trig chart keeps going, keeps going, keeps going. Going down the sine column, we have 1/2. Oh, excuse me, not 1/2. I got a little carried away there. 0, 1/2, root 2 over 2, root 3 over 2, 1, root 3 over 2, and it keeps going and going and going and going. Now you'll see here, the reason I like this problem is it says when is sine, what angle is sine of x 3 over 2? So then I go down the sine column, and I look for in the sine column when I got sine is 3 over 2, square root 3 over 2, and square root 3 over 2. And you'll see on the trig chart, the beautiful thing about a trig chart is it gives me all the values from 0 to 360 where that's the case. Now, negatives become very, very important, and hopefully we'll hit that as we go on. But x equals, in this case, there's two ways we could give our answer. We can give our answer in degrees, and some textbooks will do that, and we could also give it in radians. I think it's good to be familiar with both cases. For degrees, I see that it's at 60 degrees. Hopefully you can read that on the chart, looking at that row right there. And for radians, the equivalent is pi over 3. But that's not the only answer, is it? It also occurs at 120. And the degree value of 120 is 2 pi over 3. This is a possible answer, and this is a possible answer. Your calculator can only give you, if I plug this into my calculator, it's only going to give me 60. It's the chart that's going to give me all the possible answers. So use that chart. It's going to be very, very, very helpful to you. So then here's this, it's the same type of question, except for in this case, sine is not isolated. So what I want to do is I want to isolate, get sine by itself. So think about how your math would allow that to happen. First thing you want to do is you want to add 1. So we're going to say 2 sine x equals 1. Sine x is still not by itself. So the next step would be to divide by 2. So now we have sine x equals 1/2. Now I'm not going to draw a trig chart this time. I'm hoping that you have one in front of you that you're looking at that you can refer to. So as I look down that sine column, I definitely find 1/2. And so I find 1/2 and I'm going to put it in radians first. I find it at pi over 6. And I also find it at 5 pi over 6. That's in radian form. Sometimes your textbook wants an answer in radian form. Sometimes it wants it in degree form. If your trig chart has both radian form and degree form, you have no need of doing the conversion. But pi over 6 in degree form is 30 degrees. And 5 pi over 6 in degree form is 150 degrees. And you probably want to, I don't know if I did that on the last slide, but you want to make sure that the degrees are labeled as degrees. Radians don't need degrees. They already have the pi to signify that they are in radian form. Okay? All right. See, that wasn't too bad. Like I said, this is my favorite lesson. It's pretty simple. Here we go. We got another one. This looks, look at these two slides. Boom, 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 boom. Very similar, but leads us to a big different conclusion. So step 1 I do the same as last time. Sine of 2 squared equals 1. And there probably should be an x in there. Whoever made this slide forgot to put the x in there. Then you'll divide by 2. So you get sine squared equals 1/2. But this is where this one really takes a turn. And it all has to do with the square. What's the opposite process of squaring something? You're correct. It's taking the square root. So we're going to get sine of x equals positive or negative square root 1/2. You remember there's a rule that we learned a while ago that says no square roots can be found in the denominator. So I'm going to simplify this, getting rid of that square root in the denominator. Rationalizing it is the phrase by multiplying the top and the bottom by the square root of 2. What that ends up doing is my denominator becomes 2, and my numerator becomes the square root of 2. So now my solution, or my problem, has simplified to sine x equals positive or negative square root 2 over 2. Again, we're going to look at the chart. And last time I looked at my radians first. This time I'm going to look at my degrees first. It really doesn't matter. I'm reading a chart, same as you. Actually, no, I kind of got my chart up here in my brain, but I'm just letting you guys know that I'm trying to do the same thing as you. So in degree form, we've got 45 degrees. That's, I find positive square root 2 over 2. Looking down the sine column, I also find positive square root 2 over 2 in 135. But then if we keep going down that sine column, I end up finding negative square root 2 over 2 at 225 degrees. And I also find it at 315 degrees. That was positive root 2 over 2 and positive root 2 over 2 and negative root 2 over 2 and negative root 2 over 2. So there were 2 positive answers and 2 negative answers, but the square root is what gave us the positive and the negative. So if I look at that in radian form, the radian forms are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I hope you're noticing, and this kind of leads you into a lot of the pre-calculus and stuff, but I hope you're noticing a sequence, that you're just adding 2 pi over 4, 2 pi over 4, 2 pi over 4. This chart only goes to 360, but you understand that degrees can keep going. Like you've heard of a skateboarder who who didn't just do a 360 and spin around one time in the air. He wanted to be super cool, so he spun around 2 times in the air, and he said he did like a 720. That means he did 2 spins, 2 complete circles. You could keep going. Your trig chart doesn't tell you that, but you could keep adding k amounts of 2 pi over 4 all the way to infinity. So that could be 9 pi over 4. So you're just adding. It go 9 pi over 4, 11 pi over 4, 13 pi over 4. This year especially, pre-calc we cover this a little bit too. I just want the stuff that's on your trig chart. So even if your book asks for giving the stuff beyond that, like in this form k 2 pi over 4, I just want you to focus on what you'll find on your trig chart. Okay? Just trying to make it a little bit simpler for you. If you move on in math, you can go farther. All right? Here's another one. Very, very similar to the last one. No secrets here. The first thing we're going to do is we're going to add that 3. So we'll get 4 cosine squared x equals 3. Next thing we'll do is we'll take the 4 and we'll divide both sides by 4. So we get cosine squared x equals 3 over 4. Again, you can see that we have the square here, which makes a big difference. And so we're going to take the square root of both sides. Cosine of x equals positive or negative the square root of 3 over 4. This one I need to rationalize again, but this time I got a perfect square in the denominator. So I have the cosine of x equals positive or negative square root 3 over 2. That's really kind of good because the square root of 3 over 2 is on our trig chart. So if you have that trig chart handy, it's going to come in really, really big time for you. I'm going to give you the radian versions first. And remember, it's positive and negative square root 3 over 4. So this time I'm going to follow the cosine column. You'll probably notice that the first time you find square root 3 over 4 in your cosine column is at pi over 6. The next time you find square root 3 over 2 is a negative, and it's negative root 3 over 2 at 5 pi over 6. And then it's again at 7 pi over 6. And the one that we get is 11. The other one we get is 11 pi over 6. So there you have the 4 principal values of when your cosine equals square root 3 over 2. Here's another one. This one's a little bit different. I think this is about as difficult as we're going to get. You see here how we have a sine squared and a sine. This is very, 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 very similar to this problem here. 2x squared minus x minus 1 equals 0. This is a trinomial. There's 3 ways to solve trinomials. There's factoring, completing the square, and the quadratic equation. I don't want to complete the square or do the quadratic equation for this particular case. So what I'd really like to do is I'd like to be able to factor it. Hopefully factoring will make this a whole lot easier. The signs are going to be positive and negative. The variables at the back are going to be 1 and 1. At the front, they're going to be factors of 2. And my variable is x and x. Constants at the back are 1. But how am I going to get to these values? This one's actually a little bit simple, and they don't get very much harder than this in your lesson. It's not like we're going to be doing crazy factoring like we have in some other ones. They're usually going to be 1s and 2s. So this is going to work, but in order for this to work, because this is how this factors, I've got to put it back in my signs where the x is. So this becomes 2 sine x plus 1 and sine x minus 1 equals 0. Notice that both problems equal 0. So that actually gives us 2 equations. So we get sine x plus 1 equals 0, and sine x minus 1 equals 0. Let's solve both of them. This one, 2 sine x equals negative 1, and sine x equals negative 1/2. Over here, all you got to do is add 1. Sine x equals 1. So we're going to find all of these on our trig chart. Again, going to find radians first. When do I have negative 1/2 going down the sine column? So if I look down the sine column, I find negative 1/2 at 7 pi over 6. 7 pi over 6. And at negative 1/2 at 11 pi over 6. Where do I find sine is 1? Sine is 1 at pi over 2. And that's the only place where sine x equals 1. So if I combine those all together, I get solutions in radian form of 7 pi over 6, 11 pi over 6, pi over 2, which if I were to convert them into degrees, I get 210, 330, and 90. Okay, so that's their degrees. I got to put degrees there. And these are my radians. 6 principal roots. Okay. All right, another one. I think this is the last one. I'm not sure, though. Same thing. Going to factor. Notice how I got a cosine in each one? That means I can factor out a cosine. When I do that, I get cosine x equals cosine x plus 1. So again, got two equations. Got cosine x equals 0. And cosine x plus 1 equals 0. Again, just look, pretend you distributed that. It would equal what we have up at the top. Let's solve them both. This one's already solved. This one I just got to subtract 1. So the question is when does cosine x equal 0? And when does cosine x equal negative 1? Well, I know that it's pi over 2 and 3 pi over 2 for 0. And if I look up on the chart, I'm going to find that's negative 1 at pi. And so in degree form, those are 90 degrees, 270 degrees, and 180 degrees. Again, these are your degree answers. These are your radian answers. Okay, one more question here. This one's kind of cute. Think about if you're solving this one. Sine x equals 2. I'd like us to think back to the graphs that we have with sine. Sine, this graph looks like this. We learned in those lessons that its range was 1 and negative 1. Does it ever go up to 2? As a matter of fact, try this on your calculator. Sine negative 1 of 2. We learned how to do that. What do you get? You should get domain error. This doesn't exist. All right? Oh, I guess that wasn't the last question. This particular question, I'm going to just pass on this one for this year, COVID-19 year. One of the things you could do is you could use Pythagorean's identity here without you having the opportunity to answer questions. I want to pass on that one. Okay? Actually, I don't know. Yeah, we'll pass on it. We'll pass on this one also this year. This is a double angle identity. So you could look at that little card I gave you yesterday to help you, but without me teaching you directly in class, I want to pass on that also. I think I've given you enough information to be able to do the amended homework that I've given you. Today for this lesson, 11.6, I'm going to change the numbers. I'm going to lower them to numbers 1 to 8 and 19 to 20. All right, if you've got any questions, let me know. Have a great day. Thank you. Do your best.